think we're good to go. Super duper. Well, good evening, everyone, and welcome to the May meeting of the Ottawa Centre, RASC. I'm your host, Paul Klauninger, and extend greetings to all our club members, both near and far. Those tuning in, hello. Just wanted to also extend a special welcome to guests joining us from other RASC centres across this lovely land of ours. All right. A notice to those seeing us on Zoom, we are recording the video, and you can use the Q&A function to ask questions of the speaker. And just a reminder that the chat box comments can be seen by everyone. Also, the raise your hand functionality in Zoom is disabled. The Ottawa Centre acknowledges the trust placed in us by our First Nations with their ancestral lands and skies. And here is tonight's program. Introduction, yes, I'll do an introduction. Dave will give us his Ottawa skies for May. And then Gerry Shewan will give us a wonderful presentation on his relatively recent visit to the Lowell Observatory in Arizona. I'm looking forward to that. We also have numerous observation reports, and Richard Taylor, of course, will be doing our monthly observing challenges, and I'll wrap up with any final announcements. So we could have a short meeting tonight. We'll see how it goes, but we'll jump right into it. So welcome to new members that have joined us, especially in April. We have 6 new members and 15 in total so far in 2026. So welcome everybody. Any of the new members here tonight? Yeah, we have. There we go. Some online probably. Thank you. Well, welcome to the club. I hope you enjoy your time here. And we'll jump right into Dave with his Ottawa skies for May. There you go, sir.
Thank you. Let's see what's happening in May then. First of all, here are the phases of the moon. Full moon is tonight. And we also have a second full moon on the month. We call it a blue moon on the 31st. The first full moon is known as the flower moon. It's also been known as the corn planting moon and the milk moon. The new moon is on the 17th. We have the Eta Aquarids meteor shower, the evening of May 6th and 7th. And take a look at the moon there. Not a great time for watching them, but in any case, it's a 60 meteors per hour. As remnants left behind by Comet Halley. Best time to view is after midnight, and it appears to radiate from the Aquarius. As you can see, the days are obviously getting longer in terms of these hours of sunlight. Mercury is not visible. It's too close to the sun. Venus is visible in the early evening throughout the month. Mars is visible before sunrise in the last half of the month. First half of the month, it's sort of rising and falling with the sun. Jupiter is visible in the evening sky. It's right up there. It's quite easy to see. Saturn is visible before sunrise. Uranus is visible in the early evening for the first half of the month. Then it rises and sets with the sun. And Neptune is visible before sunrise. And there's our cartoon of the month. Thank you.
Might get a Tesla out of the deal. Thank you, Dave. All right, we have an event report because we had a super event. We had Astronomy Day 2026, and Jim Thompson will give you a bit of a synopsis of what went down. There you go.
Thank you. So, last Saturday we had our International Astronomy Day event at Chapter Silver City, and it was a huge success. These are just a few shots that I captured through the day. I don't have a lot of images because it was really a steady stream of visitors asking questions, wanting us to show them things in the sky. It was really a great day. You can see that it was a little bit cloudy, but The clouds were thin enough that we were able to share views of the sun, had lots of activity that day, and the moon in the early evening, and Jupiter were greatly appreciated by all of the guests that we had that day. So a great success. Thank you, everyone who came out to help make the day a success. Without the volunteers, it really can't happen. So thank you very much. A few more shots from the day. You can see what I meant by the sun had a lot of activity, even despite the clouds. So get your calendars out and put in May 8th, 2027 as the next date for International Astronomy Day. And I'll be knocking on your door in a couple months before then for more volunteers. So thank you very much, everyone.
Thanks, Jim. Looks like you had quite the crowd there. All right, just a quick run through of the benefits for those of you that are not members but have decided to join us tonight. Benefits of joining the club are numerous, including a whole plethora of knowledgeable folks that you can pick brains and have conversations with regarding your interest in astronomy and astrophotography. We're a pretty good group, and we don't bite or anything. So. We also have the Ted Bean Loan Library. This is our telescope loan library. We have quite a substantial collection of instruments that are available for loan to members only. We also have a book library that contains books and, I believe, some DVDs as well. So this is a very rounded club in terms of the benefits that are available to members, not just the meetings themselves, but the additional materials. Also, we have our observatory out at FLO, where we house 3 major telescopes. It's also an observing area for folks that like to bring their own gear, because the skies are reasonably dark there. It's about 4 or 5 kilometers out of Almont as the crow flies, but we don't get too much light pollution from that. It's just a wonderful setup up there, and not too far from the city. All right, as a member, you also get on an annual basis the Observer's Handbook, the quintessential guide to all things astronomy. A lot of data in there, especially useful when you're not within web range, and the web range out at FLO is a little bit limited. Some folks have better luck than others, but the Observer's Handbook again is just a fountain of good information that's been around for 50 years and still used by everybody. I use it very frequently, actually. You also have access to the journal and our monthly Astronotes summarizing events in the club, our presentations, and other items of interest. As a member, you also have access to a Discord server, which is open to our members only, where it's another forum where you can exchange ideas and images with folks that have common interest. And you're eligible to get the Astrospheric Pro version. Astrospheric is a really cool application with a lot of data a lot of real-time data in terms of weather conditions for your location, and just generally a good guide for observing and getting current information on what to expect in the skies the evening that you go out. So excellent. And this is a good value compared to what you have to pay for the Pro version if you weren't a member. So our regular membership costs currently are $118 a year. We have a family membership at $112.50 plus additional amount for every adult and youth, and we have a youth membership for students at $77.40 per annum. All right. That aside, I'm going to introduce our speaker, Gerry Shewan, and he's going to tell us all about the Lowell Observatory. There you go.
Thank you, Paul, and welcome everyone like to share my experiences when I visited the Lowell Observatory. I believe the date was December the 1st. And I was visiting in Phoenix. I was there for 9 days, and we were taking a one-day trip up to Page, where you can see the Antelope Canyon. So we saw the upper and the lower Antelope Canyon, and we had to do this quickly because we were paying for two hotels at once. So it would have been nice to stay longer at the observatory, but we had to leave in time to get to our hotel because we were visiting the canyon the next day. So without further ado, I will introduce you to the Lowell Observatory. This is the observatory as you see it pulling up. This is actually the Astronomy Discovery Center. The slide presentation will focus on the public observatory and accessible exhibits. Lowell is also a working independent nonprofit research institution. And before delving into the main part of the presentation, I'd just like to provide a bit of information on the research done at Lowell. So there are two main areas that Lowell has a strong heritage in, which is exoplanet and planetary defense, also known as tracking near-Earth asteroids. They also do research in solar system, stellar astrophysics, galactic and extragalactic astronomy, and instrumentation research. So this last bit is basically to support everything that they do. If there's a part that they can't buy, they would make it themselves on site. I don't know exactly where the building is, if it's down the hill or off the campus a little bit, but they do manufacture some of their own parts, such as potential new instrument capabilities for the Lowell Discovery telescope, and that's a telescope which is actually off this campus. And in the past, the dome to the Pluto Discovery Telescope, Pluto, that's where it was discovered at this observatory. The dome was actually made there for that telescope. And it's a very old dome, so well built. In the spirit of research, Lowell astronomers have organized and hosted a variety of professional workshops over the years, and all their research papers and annual summaries of Lowell Observatory research is available on their website. So everything from 2011 to present is available to view or download. So I promise the rest of the slides are not this busy, just this and the next one. Lowell used his personal finances, financial resources, and influence to the study of astronomy, and founded the considerable observatory on Mars Hill, which is the Lowell campus, and which bears his name. Of note, at the bottom here, you'll see that in his establishing this observatory, where it was on a very high mountain, it was 7,250 feet above sea level, and the reason he did this was for optimal seeing, enhanced image quality and sharpness and steadiness in the a more calm atmosphere at these altitudes. And this is basically what you look for anytime that you establish an observatory in modern times. I really agonized when doing this slide because I think we should know who Lowell was and what his contributions were to astronomy, and what his greatest notoriety is probably not his proudest achievement. We've probably all seen and heard of the canals on Mars, and this intricate network of canals and oases where the canals intersected. Lowell was not the first to do observations of Mars. Schiaparelli, an Italian astronomer, observed structures on the Mars surface which he called canali in Italian, meaning channels. But unfortunately, the English press mistranslated this into canals. So Schiaparelli was trying to describe the areas between the larger features and mountainous areas that he could see. And these were channels. Canali in Italian translates correctly into channels in English, not canals. So, though this Lowell's great extensive observations of Mars and looking at this network of canals was subject to some ridicule, his impact, Lowell's impact on society today was huge. We have future space missions, our general thinking toward life beyond Earth, and sci-fi literature and movies. You know, we have the War of the Worlds. Probably that's not a great one to mention because some people actually died jumping out windows the first time that aired on radio. But if you're a lover of science fiction, you just might have Lowell to thank for that indirectly. So here's a comparison between what Schiaparelli saw and what Lowell saw. They don't really look the same at all. Of course, Schiaparelli's is shown as an equatorial projection, so it's not quite the same as the projection we're looking at as a globe in Lowell's projection, but Lowell had these very fine lines on the surface of Mars, which he thought were canals. So the reasons for what Lowell saw, in addition to the mistranslation of canali into canals, and I will admit I had to use a little bit of AI to do this research myself. Two of the next 3 points were from that AI search. The quality of telescopes in the late 19th century was one of the reasons. Optical illusions from limited telescope resolution. The human brain tends to connect faint patchy albedo features. Albedo means reflection, so the brightness. It connects those features in continuous straight lines, a well-known perceptual phenomenon called pareidolia or illusory contouring. And another reason was human pattern competition bias. The brain tends to impose order on ambiguous stimuli, producing straight lines where none exist. And the other one, I think, which is well known to those who are familiar with Lowell's work, was Lowell was so deeply invested in his work that he drew what he wanted to see based on his beliefs on the existence of a Martian civilization. So, unfortunately, in his time, Lowell was not considered to be the greatest scientist because his science was informed by his observations, which were not great at the time. They were very faint observations, and that's the only thing that his theories were informed on. We don't have spectroscopical analysis and this kind of thing, and satellites orbiting Mars to give us a better view of what exists on Mars. So I've taken these images from Google Earth to show a timeline here. This is a recent one showing the observatory, the Astronomical Discovery Center in its finished form, this building here. And prior to this date, everything from here to the left did not exist, and you'll see that in the next slide. So this is 2003. This is a very new building which was built to make astronomy at Lowell more accessible to the public. And you don't even see the parking lot completed here. So the Lowell Observatory in 2005 with Astronomy Discovery Center is complete. And this was only complete as of the 16th of November, so 15 days before I arrived there. So I happened to go there at a very opportune time. There are other telescopes managed under Lowell Observatory, which are off-site, and they're listed here. Anderson Mesa, 19 kilometers southeast of the Lowell Observatory, and the Lowell Discovery Telescope. This is the 5th largest aperture telescope in the world. And it's called the Swiss Army knife of telescopes. It can be done in many different configurations, and it's mostly in the Ritchie-Chrétien configuration right now, but there are different instruments that can be attached to it. So at the entrance to Lowell Observatory, we see some things that'll get the kids excited, and we have the Mars Perseverance rover with some little Martians there, and the kids are going to get pretty wound up when they see that entering the observatory. So on the Lowell campus, we have the Astronomy Discovery Center, which is the main building I showed you in the Google Earth images. You have the Putnam Collection Center, which I will go into later. It's really cool. You see a lot of the historical artifacts there related to Lowell and other discoveries. And we have the main telescopes that are listed there, the Clark Refractor, the Dyer Telescope. I didn't happen to see that one, and the Pluto Discovery Dome. And then there's the GeoVale Open Deck Observatory, which I will show you later. Has a number of advanced telescopes, and this will probably remind you of something that Ottawa Centre has. The Origins Gallery is a centerpiece to the Astronomical Discovery Center. There's a model of, the design of this building naturally brings attention to the center, so you're always seeing this model in the middle, and all the exhibits are accessible from the center. So there a lot of thought was gone into how this building was designed. On one of the walls in the second floor of the Origins Gallery, we have a wall of quotations, and we have one from Stephen Hawking. You may not be able to read it there, but it says, "Try to make sense of what you see and wonder about what makes the universe exist. Be curious." And we also have a quote that I really liked from Einstein, here being Einstein the philosopher. Slide 14. I should just 13 actually. I should add here that on the left they have attempted to simulate the smell of comet tails and different celestial objects, knowing their chemical composition, so you're not actually smelling comet tails and interstellar gas. And on the right, you can actually touch what they've tried to replicate the surfaces of some different objects in the solar system, allowing viewers to touch them. So they want you to use your senses to experience astronomy. This is one of my favorite exhibits, and this is one where you can select one of 12 well-known meteor showers and have the actual cloud of debris that orbits the sun displayed on a large TV screen right in front of you, and see how it cuts through the orbit, Earth's orbit around the sun. Are we actually able to run the 2-second video on this, Chris? Oh, okay. Oh, there we go. So they show an animation of every orbit, and depending on which one you select, it intersects at a different angle and a different time of the orbit where Earth is in its orbit around the sun. So I thought that was very well done and intuitive, and one of my favorite ones. Here's the infamous Drake equation. So the visitor can come in and he can enter all of his own coefficients, 6 in all, to the Drake equation. And this was my attempt to show that the Earth is the only planet in the Milky Way galaxy that could be a communicating civilization. So you enter the percentage of planets that might develop life, the percentage of planets that might be habitable, and so on and so forth, and you come up with a number. Here's the orbit's curiosity zone. I did not go here, but it looked like it would be fun if you were a kid. Blow off a little steam, learn about astronomy. The Lowell Universe Theater is a 180-seat theater, and it's state-of-the-art, of course, because the building is so new. It has a 2-story tall LED screen. We were lucky enough to see the Cosmic Highways Centennial Tour, and that allowed us to have a little tour of the Putnam collection right afterward to see some of the historical artifacts that were on display that we learned about during the presentation. The Putnam family is actually related to the Lowell family, so kind of explains why they have their name there. On the roof of the Astronomical Discovery Center, we have a dark sky planetarium. Not the type of planetarium that you would typically think of when you hear the word planetarium. This is open sky. There's no roof on it. There's no projector. There is a TV screen on the front here. And all these seats are heated. When we were there, it was below 0 Celsius, so quite cold. But they showed us some constellations in the sky with their laser pointer. They saw a plane going by. They said, nope, can't use a laser pointer right now. So they were also teaching us some responsible things about laser pointers at the same time. And this is the Putnam Center collection, which I spoke of earlier. So you will see on the right here, this is Lowell's first telescope. And down the lower left, this is Slipher's spectrograph. And Slipher was responsible for, largely responsible for the proof that the universe is expanding. He was able to detect redshift in most galaxies that he observed and to show that galaxies are moving away from us, and the farther away they are, the faster they're moving away. So he is one of the famous astronomers that was working at Lowell Observatory early in the 19th century, 20th century, sorry, early in the 1900s. This is Percival Lowell's big red car, and this car was lost for decades, found in somebody's barn, so it took quite a bit of work to restore it to its very new-looking current appearance now, but he was a very wealthy man, and to afford a car like this in 1911, you had to be quite wealthy. This car was built to his personal specifications. So now we head outside. There's plenty to room as you traverse the sidewalk, plenty to read as you traverse the sidewalks and the extensive outdoor displays. There are tons of displays. We couldn't see them all. Just weren't there long enough. GeoVale Open Deck Observatory, which I spoke about earlier, it houses 6 advanced telescopes. It was closed when we were there, and I took this image off of their website because it shows the observatory open. I guess it must have been taken from a drone, given the view that we have there. So this is very much like FLO. The roof rolls off, and you can observe one of the telescopes there. Actually, that's in a subsequent slide, is a solar telescope. Now this one, so when I was walking up to the open deck observatory, the guy working there says, "Oh, we have a visitor, he doesn't have a ticket." So if you look in the center of the screen, you'll see this crawling thing there. This is a tarantula. It was 0 degrees outside, and we're on top of a mountain. I did not expect to see a tarantula when I was visiting the Lowell Observatory, so I'll look at that again. Let's go back and look at that again. There we go. You see it? Right in the middle. Here are the various telescopes on the open deck observatory. This one here, this is a solar telescope. I did not get a chance to look through any of these telescopes. They may have had viewing on them in the evening, but I was in some of the bigger domes at that time. Also inside the open deck observatory, they had more information on the walls, how telescopes work, explaining that, and some information about the visible spectrum. So there's no wall space wasted in this observatory. It's just amazing how much they're able to fit in to basically showcase astronomy to everyone. There's the observatory at night. It's just a beautiful landscape. You're in the top of a mountain. The sky is very clear. It's just a beautiful setting. And look at this, luminescent sidewalks. So you're not going to trip and fall down like I've done before at FLO in the dark if you don't have your red flashlight, and even at times the red flashlight doesn't help. You trip and fall anyways, but not here. This is wonderful. There's a very long sidewalk there, long and straight. I think it must have been close to 150 meters long, a scale model of the solar system. And on this sidewalk were metal discs, maybe about the size of a quarter, with the name of the planets. You probably can't see it there, and sorry for that, but I had to shine my red flashlight on them and try to take a picture of it. And on my computer, trust me, if you blow them up really big, you can see the word Neptune or Pluto stamped into those little discs. And so they have these little discs spaced according to their distance from the sun. And as you're walking, you're starting with the sun. Mercury's very close, and then Venus, and then Earth. And the distance are gradually increasing as you walk, and then comes Mars, and then a fairly big gap as you traverse the asteroid belt. You're getting the idea of just how far apart the planets are spaced as you walk past the gas giants. And then we see Neptune at perihelion. So sun's over here, moving this way. And then Neptune at aphelion. I'm sorry, Neptune at aphelion, Pluto at perihelion. And before you say, hey, Pluto doesn't belong there, this is supposed to be a scale model of the planets in the solar system. In case you didn't know, in the state of Arizona, Pluto is officially recognized as a planet. They do not want to diminish the discoveries that were made in the state of Arizona. But, of course, you have to realize this is the United States. So here is the 24-inch Clark Refractor Observatory, built in 1896, so 2 years after Lowell had established the observatory on Mars Hill, and still in use today. Here are some of the uses by Lowell in his famous observations of Mars, study of spiral nebula, and mapping of the moon for Apollo missions. And note the wood. This dome is made of wood. And given the altitude of where it is and the very dry climate, wood makes a very good choice for dome construction. Again, another wooden dome. This is the Lawrence Lowell Pluto Discovery Telescope. I'm not sure if it was a brother of Percival. Related to Percival, anyhow. He must have put up some money. This is the Pluto Discovery Telescope, where Pluto was discovered. And this is not a working telescope. You'll note right here, we have where one would normally expect an eyepiece, there is a photographic plate instead. And this would be where those famous plates where they did the blink comparison of, the image of the sky one day, and then again, I'm not sure what the time period was between the first image and the second image where they saw that little dot move. But they would have been taken on these photographic plates that you see at the base of the telescope. And there's other nighttime accessible exhibits. Note how we have the red color, so very night-friendly vision, and you can read these plaques at night. Guess what this place is? Anybody? A man who loved his work was buried with his work. So Percival Lowell is buried there. There he lies. So just summing up everything, so started in Phoenix, saw a lot of these saguaro cacti on the way there. I believe this is near Sedona, very red in color. A lot of rocks like this, and you've probably seen Bugs Bunny and the Roadrunner, and a lot of landscape like that. And of course, from there we went to the Lowell Observatory on our way to finally see this. And this is the Antelope Canyon. I believe this is the lower canyon. And what this is, it's a rock which is carved by fast-flowing water after a flash flood in the desert. Over many, hundreds of years, these things have been carved deep into the rock. And I think we're probably down maybe 50 feet below surface when we're seeing this. And you see the light coming in. The colors are just amazing, especially in the lower canyon. So that concludes my presentation. I hope you enjoyed Lowell Observatory as much as I did. And if you ever get the chance, please go. You will not be disappointed. I've been to Griffith Observatory in Los Angeles. I thought that was great. It was great. This is better. And thank you for your time. Okay.
Well, thank you
Thanks.
so much, Gerry.
Welcome. Ah, there it is. Keeper for my laser pointer.
Ah,
Gerry, can I steal the slides for Astronomy?
Can I email them to you after the meeting?
Or I should have access to this stuff. But yeah, if I can't get access, I'll email it. For sure.
oh, question? Who was?
So when, like, you show one of the first pictures where like very much of the canyons, like the canals, just meet together. I think I saw Mount Olympus there. Yeah. Is it Mount Olympus? Because, yeah, like, what?
You mean Olympus Mons?
Yeah.
It might have been in Schiaparelli's. It certainly wouldn't have been in Lowell's. Oop.
Oh, like where all the canals meet together, like.
The one that says Hellas, maybe, in the middle?
No. No, it's on the Lowell thing.
Oh,
Because I saw like one of the like big black dots, and I think it's a volcano. It's Olympus Mons.
I cannot say. I'm sorry. I don't know.
Possible. Any others? No? No? All right. All right. I'll give folks just a chance to get back into their seats. And again, sorry about the disruption in our schedule there. It seems as though we've had a miscommunication there, so we will try to schedule Andrea for later in the summer. And yeah, sorry about that. You can get an early night's sleep tonight. All right, so we have a bunch of observation reports, and we're going to start with Bob Olson. Are you there? Oh, there you are, man in the shadows. There you go, sir.
Chris will run them.
Oh, okay.
Yeah. This galaxy is about 46 million light years distant and is composed mostly of dwarf stars. This image uses 6.5 hours of exposure this year, combined with exposures from 2021 and 2022. One interesting detail of this galaxy is that it contains a spinning neutron star that is a very strong X-ray source. That's a pulsar. It spins about once every 1.1 seconds, and this is only possible if it is not very big. Neutron stars typically measure only 10 to 15 kilometers in radius, but have a mass roughly equal to 2 times that of our sun. A single teaspoon of neutron star material would weigh about 1 billion tons. Okay, next one, please. This is both a reflection and emission nebula. It is about 2,400 light years away and contains many newborn stars. I find it looks like a modern art painting. There are several satellite tracks in this image which I didn't totally remove in processing. I don't know if you can still see them or not. This image was taken over 7 nights of imaging and has about 56 10-minute exposures for a total exposure time of slightly more than 9 hours. Thank you.
That's great. That's a nice piece of work, Bob. What telescope were you using for that? 12.5 Newtonian. Yeah, really nice piece of work. All right. How you doing?
Pretty good.
Jim's got some good stuff for us.
Good stuff. Okay. So this is a close look inside the Rosette Nebula, NGC 2237, taken with the William Optics 81 millimeter refractor and Mallancam Skyradar camera. This is approximately 15 minutes of exposure time. The Rosette Nebula is a vast star-forming region, 100 light years across and approximately 5,000 light years away. The Rosette emits colorful hydrogen gas and has open star clusters embedded within it. Thor's Helmet, NGC 2359. This is an emission nebula in Canis Major, 12,000 light years away, and an astonishing 30 light years in size. The blue-green ionized gas, illuminated by a massive Wolf-Rayet star, forms a helmet-like resemblance worn by the famed Norse god of thunder. This massive star is thought to be in the pre-supernova stage of evolution. And here is M66 and M65, part of the Leo triplet without the Hamburger galaxy, which is a half a degree away. Note the asymmetry in the spiral arms and core of M66 on the left. And one reported possibility for this is, and there are other explanations for why the galaxy looks the way it does, but one that I read up about was that there is an influence, a possible influence of the gravitational pull of the other two galaxies in the Leo triplet, which is causing this asymmetry in M66. This particular image was taken with the Mallancam Skyradar 432M, and it's the exposure time was approximately 8.5 minutes, and I was using a ultra high contrast filter for this image. Okay, moving along. I have 2 examples of solar flares. The first one you just saw shooting out from this area right here. A flare is a localized emission of electromagnetic radiation, which often occurs in active regions of the sun. And as a matter of fact, we're looking at an active region right below, right here. You have your sunspots, even though it doesn't look like a sunspot, there's a sunspot there, there's 2 sunspots there. And this is a plage area, lighted surface area of the sun, which signifies a high magnetic field, along with some visible plasma. Okay, and the next example, because the next example may give the illusion during an animation loop that the flare or burst of plasma, which we're talking about right over here, occurred so fast in the beginning. And the reason why is because this is the first frame of the animation. So unfortunately, what is missing is we don't see how the flare emerged from the solar surface at the very beginning. Timing, but that's just the way it happened. And so I wanted to show you this before seeing the video because the flare seems to appear out of nowhere. But that's only because that there's some data missing. So looking very close up, zooming in every 10 seconds, the sequence replays. No tricks, no light speed antics, no you did not blink, just a piece of solar history. Thank you.
That's a nice piece of work. Nice catch on that flare, Jim. Just out of curiosity, your deep sky stuff, are you shooting that from home or do you go off-site for that?
Right off the balcony.
All right. There we go. Oh. Taras, you got some goodies for us too today.
Thank you, Paul. Good evening, everyone. This comet called C2025R3 Pan-STARRS was putting up a show in those areas where you could see it clearly. It would produce 2 degrees long tail, was quite bright. The pictures were amazing. I decided I must see it, must take some pictures. So on April 11th, a rare opportunity with relatively clear skies, and that was the only day so far when that comet was visible more or less from our latitudes rather, and we I didn't have other chance, so I wanted to see what it looks like. I went to place the entrance to the Mill of Kingtail with the equipment. And as you see, there was not much luck because towards the east, first of all, from that place, there is a bright light dome from Ottawa. Secondly, that was the only place that was clouded, and the clouds were just, as you see, whereabouts where the comet is. So, quick moment, about 20 seconds, when there was a bit opening between the clouds, when I took a few subs, and this is all I got. Like you can see the 3 times magnified view, and it's not worth of publishing as a beautiful picture of the comet, but at least the checkbox is there. I saw it, and I did my best at 4:30 a.m. to catch it. You can see the bright light of sun rising soon, so was close to the sun already. Now it's even closer. Probably the chance is lost now. The other day, I think this was on April 17th when we had the star party at the Fellow. The story was similar. We had the clouds, more clouds, and there was quite long opening for, I won't be afraid of saying, 1 hour between the sunset and 9 o'clock when the skies were relatively clear, but I arrived at 9 o'clock and the clouds came in. So I waited until 1 o'clock a.m. or 12 o'clock for them to go away, and I took this picture of the moon. This time it's color picture with RGB filters and monochrome camera, but they're combined to make up the colors. You can see a little bit of bluish glow here in Sea of Serenity, and some prominent features would be the Aristoteles crater, Cassini crater with 2, it looks like a nest with the places where 2 eggs were stored or what, and the Archimedes crater. These are Mons Caucasus, if I'm not mistaken, and Alps. There is Alpine Valley here. So that was quite nice seeing, so I'm glad that I waited. So I was able to take this picture. The same night, so not sure if it was no, this was actually in February. So this was the night of one of the best seeing so far this year when I used the 18-inch StarMaster to image Jupiter and a couple of moons. I believe Io is the closest, and this is Europa here on the right. The only special moment about this picture is that it was the closest to the opposition. The opposition was January 10th, and this was taken already 1 month later, so the planet was still relatively big, and the resolution of StarMaster, let me take this again in RGB, plus I used a little bit of infrared information from the red channel through the, from infrared channel. I added it to the red channel and mixed it a little bit. Now, April 7th, we had an event where Io, which is this little tiny dot here, was transiting the surface of Jupiter, and there was a shadow from Io on Jupiter surface. Also, the red spot would start to show up, and another moon of Jupiter, the very same Europa, is here on the left. So I took actually a sequence of this, and this will be only 8 frames. Again, it's a bit tedious work to take these pictures with a monochrome camera, because for each shot you take at least RGB and sometimes infrared, combine them, process them, and so on. So I cheated a little bit. I took those 8 frames, but I interpolated it with AI software, which does the frame interpolation. And I've got this, so you can see how Io moves, and the shadow follows it. There is a bit of red spot showing up as the planet rotates. So again, it was only 8 frames. It's not perfect interpolation. Not sure if I can go back and replay it again. Chris, can we replay it again? Thank you. So you see that the moon disappears sometimes. It's a result of imperfection in that interpolation software, but it did what it could. And so April 11th, the other clear night with the nice seeing. Not sure actually, I don't remember whether this was taken with 18-inch refractor or the 14-inch Meade. I believe this was actually 14-inch Meade telescope, which is one of the other 2 that we have at FLO. The only special thing about that is that, except for these 2 moons, which is again Io and Europa, we see the Callisto here with a little bit of kind of like details showing. So the largest moon, Ganymede, though, probably is the best candidate for revealing some in-depth, tiny little features, but it was not in the field of view, and I didn't realize that it might be actually a good opportunity to take it as well due to improved seeing. So speaking of those 3 telescopes, this is the way you can compare the image from each of them under about the same imaging conditions, the same sky quality, and they are taking about the same period of time. Schmidt-Cass on top is 14-inch telescope, which you can take course from Paul how to operate or read the manual and confirm that you know with Paul how to use it. Probably getting some instructions is a bit better idea. The StarMaster, that's Rick Schultz, who can provide you courses on how to use that one, and 6-inch refractor. I actually found out that the contrast of refractor is the best. It does give you a really nice, clear picture. Probably slightly less amount of details than 18-inch Star Master, but it kind of makes sense because the larger aperture you have, the higher chance that under good conditions you can reveal more details. This is an interesting one. So I got a CH4 filter for methane, and the same night when I was imaging the Jupiter from that previous slide with Europa, and I think the other one is, actually no, the closest one is Io, and the other is Europa. So this is the image of Jupiter in methane band. It's quite strange what it looks like, because we used to see that it's actually oblate spheroid, while this one does not look like that. Moreover, you see that the both poles, north and south poles, are for some reason much brighter than some bands. And of course, you see the bands themselves. And yeah, the shape is strange. So I don't know the answer about the shape, but the density of the bands, including those on the poles, they correspond to the thickness of methane in those regions. So the filter works that way, that the thicker layer of methane there is, the more of light it would absorb, and it would reflect more where the layer of methane is thinner. So that's why I guess it makes sense that on the poles, if there is a thicker concentration of methane, you get these brighter strips or areas with more methane showing as brighter.
Taras, I'm just going to interrupt because in Zoom there's a question from Rick Wagner on this slide. What is the bright spot near the lower limb?
It's not visible in visual range. I think it's one of those darker spots that are relatively small, but it is not the red spot. The red spot that night would have been on the opposite, also on the lower part, but on the opposite side. So it does show some details like that brighter patch, but visually when I tried to relate to it, there was nothing really distinct. But again, this was also after some period of time when the planet rotated a little bit, so I don't have the exact location for that region, but at least it was not showing even on the rim. And I know almost certain that the great red spot would have been on the other side. And the same April 11th night, Venus. Actually, I took two shots of it, April 11th and April 24th, using visual, which is the top row. Again, it's a combination of RGB. And on April 11th, infrared filter. So the lower part of April 11 is infrared only, stacked. What is special about it that is more crisp, seems to be more in focus than the other images. It's because the infrared light is less susceptible to the effects of bad seeing, and it's much easier to see the shape of the planet, or at least for the camera, because our eyes cannot see it. So the camera gets a little bit better signal, and after stacking, the details are more crisp. And the lower part of April 24th on the right is visual in combination with UV, ultraviolet. So there is, so I forgot to add that the previous slide with the methane filter, the wavelength was 890 nanometers, while for visual UV it's about similar, for UV it's 350. So it's really susceptible to the effects of bad seeing, but with stacking and combination of other channels, I got this image which shows a little bit of coverage, cloud coverage. The bluish area is where there is less thicker or thinner layer of clouds on the Venus, and this yellowish or orangey is where they get a bit thicker. So there's not much details in this, and I compared this with other pictures about the same time. It's just like a V-shaped band of clouds, and we will probably get more better view of that when the planet gets closer to us, which is with every next month it will be on approach. But what also will be happening that this phase will be turning into almost like a crescent, and the closer to us, the more prominent and narrower the crescent will be. So it will be, again, more difficult to get the shape of clouds if it's a crescent shape. Thank you.
To RASC, just one interruption. Pass on a comment from the Zoom audience from Greg Beaton. Wow, I think that was the best image of the moon I've seen.
Yeah, definitely. Nice work on that. All right. Oh, that's me. Just a couple of moon shots for you that I did, I think, 3 nights ago. I've been doing a bunch of stuff with the moon lately, some of which I'll tell you about in future observations. 3 nights ago, the seeing was, it was okay. It wasn't horrible, but the sky was very transparent. So I've been focusing a lot of stuff on the terminator of the moon there, because that's where you get a lot of relief from the shadows, the shadow detail there. So this is not a photograph. This is just a map from the virtual moon atlas. That's an excellent application for those of you that want to do some stuff on the moon there. You can zoom in, you can get information on the various craters and such. And it also gives you very precise timing in terms of when the moon transits, and more importantly, for some of the stuff that I like to do in terms of the libration in the libration zones at the North and South Pole and on the eastern and western rims. So it's chock full of information, and it's a free download. So if you've never heard of it, check it out. It's pretty good. So just like I said, a couple of pictures. The first one I've got is one of my favorite regions there. Is Copernicus, and I'll run through that. As you see, the seeing wasn't all that great, but what I liked about this particular time with the shadows is the relief that it brings up in and around Copernicus. You can see the ejecta blanket from Copernicus spreading out over the ocean of storms. Rather impressive, and for the really clear nights, you can use a lot of magnification if you're a visual observer to, oops, sorry, got the wrong one. Go back to that. To zoom in on the central peaks area. This has a very complex central peak formation, similar to the Kepler crater, which is just off to the side of it there. But I really like what you can see here in terms of the topographic relief. And what you can see also is, if you look closely at this, and again, I apologize that it wasn't the sharpest of nights, but you can see there's a lot of hills and material that's upraised. These are not all craters, and the way you can tell is that on a crater with this illumination, you can see the far wall, the western wall being lit up, whereas on the hills, you can see the eastern wall lit up there. So this is quite a hilly bunch of terrain there. A lot of this is believed to be ejecta material from the actual impact that created Copernicus. All right. The next one I've got for you is, oops, again, back off there. Too heavy on the button. This is actually really one of my favorite regions on the moon there, because it's such a dramatic structure there. And on this night 3 nights ago, it was just at a really nice position in terms of where the terminator was, to highlight some of the really subtle details that are associated with this structure. So there you can see the shadow just moving in, as tonight this whole area would be under light, whereas here you can just see very shallow angles of illumination. It really highlights the Jura Mountains, which are this part of the rim. This basin itself is about 260 kilometers across. And what I like about this region especially is this stuff. You can see the ripples here, and they extend down further as well, but the really cool around the sinus iridum basin itself, because what these are lava flows. This is, you put your imagination to work here. This is an area that got flooded by molten rock from a massive impact that formed the Embrium Basin, the larger basin down here. The rock was molten and flowing across the surface there, only to freeze in the cold of space and create these frozen waves, if you will, of material that mark the progression of those lava flows. It's quite a fascinating structure, especially when you dive into the geology of how this thing formed. One of the other experiments that I ran with this, just because I like playing with perceptual stuff in terms of how we see things, especially when we photograph or image things, I inverted this image. So black becomes white, white becomes black, grays changed intensities there. So have a look at the ridges here, the lava flows, and then have a look at them in reverse. And you can see when you flash back and forth between the two, which I'll try to do here, you can see different perspectives on the extent of those flows. I mean, in terms of reality, we would never see sinus iridum illuminated like this, because that would basically require the sunlight to be coming in from the north, and we just don't see that on planet Earth at all. But reversing it like that gives you a feel for the flows. I find it also brings out the small details on the craters there. The craters that would, I'll go back again one more. Craters that might not be readily visible or just appear as faint white spots, when you reverse them, oops, I will get the hang of this button. When you reverse them, I find that they stand out a lot more because they're darker. The contrast is there. So the reason I'm showing this tonight is especially for relatively new observers. In terms of getting into astronomy, and that the moon is always a favorite target, but sometimes it's difficult as well because it's so bright that you need filters in front of your eyepiece if you're doing visual astronomy, because it'll ruin your night vision, and it'll actually, if you look at it too long without filters, it'll probably give you a headache. So filters are recommended, and what they can do is they can help adjust the contrast so that you can see these subtle things, because as new observers especially to looking at the moon, most of the richest detail that you'll see is along the terminator. That's the dividing line between light and dark, where the sunlight is hit and where it hasn't yet illuminated an area of the moon. It tends to cast long shadows, and like this one, I love this one in particular. This is the promontory at the end of the Jura Mountains there, and I'll flip back. That white streak is the shadow of that mountain, casted onto the relatively flat plane there, and you can see, because of the very shallow angle of illumination, that this is quite a pronounced peak there, and its shadow stretches back quite a ways. Some of these mountains stretch actually over 3 kilometers above the surrounding flat region of the sinus iridum bay. But yeah, fascinating region. And when you go down, unfortunately my window was a bit short there, and I didn't get down all the way that I wanted to in terms of catching some of these features. But if you move along down this way, especially at around the same time of illumination, you'll get into some really neat volcanic features like the Marius Hills, which is a whole flock, if you will, of volcanic domes on the moon, which is something that you don't see all that often. Most of the time, when you think of the moon, you think of craters and holes blasted into the ground. But there was active volcanism for quite some time on the moon, and some of those remnants are still visible. Sometimes you just really got to hunt for them, though. So that was that's my observations for this month. All right. And I think, oh, thank you. I think, do we have one more? We have our observing challenges. Oh, Fred, where are you, Fred? There you are. There you go.
Learn how to use this.
The big one advances it. That's
Okay.
the laser. And if you want to go back, it's the red one.
Great. Good evening. My name is Fred. I've been doing astrophotography for about 4 to 5 years now. Yeah, so this is the Needle Galaxy. I'll show it to you in a second, but back in February 14th, I attempted this with a smaller telescope, Newtonian, and I wasn't satisfied with it, but I then took it again with a larger telescope. So I'm just going to show it to you. So this is from Wikipedia. It's, as you can read, it's 30 to 50 million light years away. It's an edge-on galaxy, and it's quite bright. It's actually, I believe, it's brighter than Astronomy. Okay. So the first capture was done on the 14th. I used a Skywatcher 130p, one of these older telescopes back, I guess, 12, 14 years ago. I bought my first telescope, but I never really got into using it too much, and I put it away for about 4 years or so. And then I ended up getting another telescope after that. But then I came back to this one once I acquired a better mount. So I ended up getting a HEQ 5 Pro. And then recently I got this 533 monochrome camera. And this next image was taken with 30-second images of each filter, and a total of 1.5 hours. And the way that I processed it in Pixie Insight, I just used the batch processing script. I applied NBE, and then I removed some blue from using SCNR. Oh, sorry. Yeah, so this is my small little telescope. I'm still working out a couple of little changes. I just bought a new computer there to put on literally on the telescope instead of a box on the ground. So this is what that telescope produced just in 1.5 hours. I did it again on the 11th using a Skywatcher 250p with pretty much the same camera. And however, the focal length on this telescope is a little longer. It's 1200 millimeters, and for some reason I have a problem with this mount, which was the EQ 6 Pro. So I pretty much did it the same way. However, I believe I processed it in Gray Expert after it was converted to non-linear, which was not what you usually would do. So this is the telescope. I usually shoot from my backyard. There's a computer in that little box on the table. And that night I did a meridian flip without even being out there, and luckily it didn't pull it off the table and crash everything out, but it magically worked out. And this is what that telescope did. So there's a little bit of noise in the processing side, but hopefully I can get better over time. So that's pretty much it. I just wanted to show you another quick capture that I was very proud of getting back in December 21st. And I'll end with that. But right now I have to solve this stickiness with my mount. I don't know if there's somebody that's knowledgeable on how to rebuild mounts in this committee or this group, but I may reach out to you. So this was on the 21st of December. I had a all-sky camera set up, I believe doing 9-second exposures. This was almost like a double fireball, but it's just a medium size. I was been inspired by using all-sky cameras over the last 2 years, just changing all the different, exposure times, using it for auroras, and I just needed to get better. So I bought an NVR, like a network recording device, and a IP camera, and I managed that night to capture this exact same meteor after setting it up for about 18 minutes. Normally, to capture something like this, if you're not trying hard, it takes up to 200 hours. So this is the raw video one of it. I don't know if I got to push again to make it. Okay. So, and so this was quite a rewarding. I've been doing this for so long, and I wanted to have it in like a video format, and I managed to get it that night. So I then cropped it and to make it a little bit better. This IP camera actually picked up the sound as well at that night, but there wasn't really much sound. But you could hear a little bit of a hiss. Basically I just got this camera out, a long Ethernet cable going into my patio door during the cold air outside, and leaving it running overnight, and then the next day I would process and look at the all-sky camera, see if there was one, then look at the same hour of the NVR's data, and then luckily this one I captured. So that's pretty much it. Thank you.
Thanks, Fred. Good lucky capture on that. And nice detail on that dust lane, by the way, in the needle. That's excellent. All right. Mr. Taylor, good to have you back. I hope your trip to New Zealand was worthwhile.
It was really fantastic. So I hope I'll be able to tell you more about the whole detail of the trip later on after I've got all the pictures processed. I'm processing them very slowly right now because I took literally thousands of pictures while I was there. Anyway, thank you very much to Jonathan for proposing some challenges for this month. So I've tried to meet those challenges with some of the pictures that I did get in New Zealand. This was an interesting night. I was in a little town just beside the coast of the eastern coast on Hawke's Bay. If any of you are interested in white wines, that's the white wine district, and it was a lovely place to sample some of those too. But that night I was very lucky to have a nice clear night, so I set up my new Sea-Star telescope to take pictures of nebulas. And then I sort of said, oh, well, what am I going to do now? I'm looking around and my tripod is in use, so I can't set up anything else on a tripod. I only took one with me. But then I was looking at the stars on the northern horizon and thinking, I should be able to recognize it. We share some areas of the sky. If I'm looking north, I should see what we see from Canada. But boy, was I ever disoriented. I could see Orion. Orion is, big and bright and very distinctive shape, but the sword was pointing upwards. And so with that in mind, I sort of started looking around again, and then I thought, oh, now there's a curve of stars there, and the bright star is on top, Regulus, and the sickle, or the head of Leo, or, as I said back in March, this is the constellation of Mishibitsu. And we have, there we are, the head here of the puma, or the head of Hydra in the Greek tradition, and then the body and the curly tail. But of course, it's all upside down. Now, this is also interesting because, as I said, I didn't have a tripod. The only other thing that I had available that night was my iPad. So I leaned the iPad up against a deck chair and took a long exposure picture on the iPad. So this is just to show that you don't need a whole bunch of fancy equipment. Your phone or your iPad or a tablet or anything like that, they have very good cameras in them. There are apps available to let you take long exposure pictures, and tripod, yeah, a deck chair will do. So that's what I did for this one. Another disorienting picture, and one of the challenges, was the moon. We were walking back to our hotel after dinner on April the 1st, and April Fool, the moon was rising upside down. So once again, we have Tycho up here at the top, and Merecrisium is over here on the left. So it was quite disorienting to see this particular view. I've left in the trees and buildings that it was rising above, so you can see I didn't manipulate the picture afterwards. This is exactly what we were seeing, the moon rising upside down. And then the next challenge was also a nebula that you're not familiar with. Well, that was the fun stuff. Oh, sorry, no, it was a star, a real cool star. So first of all, here's the Milky Way as seen from the southern hemisphere. And this was looking towards the east where the Milky Way was rising, and quite brilliantly you could see this star here, and in fact a pair of stars. This is Alpha Centauri, a very famous star because people call it the closest star other than the sun to the Earth. It's not exactly true because it turns out that the Alpha Centauri star is just the brightest star of a collective. There's several stars orbiting around each other, and there's one star called Proxima Centauri, which is actually just a little bit closer to us. But it's, I think, a red dwarf, so not very easy to see. It's in this frame, but I'm sorry, I can't point it out. It's too small and faint. So Alpha Centauri, very famous, and Alpha and Beta Centauri form a pointer pair like the Big Dipper, but this points up here to the Southern Cross, or crux. And that, of course, is on the flags of both New Zealand and I believe Australia as well. Very bright constellation, but it doesn't look as much like a cross as the Northern Cross because there's no star in the middle of it. So you have to kind of imagine the shape of a cross. However, the other thing that is close by is a dark nebula, the coal sack. So it's definitely a dark patch in the Milky Way, which is quite easy to see with the naked eye. And in fact, the Aboriginals of Australia called it the head of the emu. And later on in the night, when the Milky Way rises even higher, you can see the neck and the body of the emu somewhere down here. Looking farther up, we have a very bright area of the Milky Way here. And in the picture, you're actually seeing a bit of redness. That's the next object I'm going to show you. That's the nebula, the Eta
Eta Carina Nebula. But while we're on this picture, there's another little cluster here. Again, we never see it from this latitude, but that's the southern Pleiades. And yes, it does look very similar to our Pleiades in Taurus. A cluster of stars, but fairly big, so you can actually see the individual stars with your eye or with a pair of binoculars. So quite a different experience seeing the Milky Way from the southern hemisphere. And now zooming in on the nebula, that's what my sea star was taking pictures of. And this is about an hour and 45 minutes, and it was the first time I'd actually successfully tried the mosaic mode, where it keeps moving the telescope around as it's taking pictures and builds up a field of view larger than any individual field of view of the camera telescope combination. This is a huge nebula. It's bigger than the Great Orion Nebula. Not quite as colorful, perhaps, but very complicated. Lots of dark dust lanes going through the middle of it. So a beautiful, beautiful object to both observe visually and to take pictures of. So that's my observations for this month. Moving along to the challenges, or these are the challenges that we had for this month. I didn't see very much activity on the Discord server because I don't think the challenges were posted there this month. But we did see quite a few pictures, very nice pictures of the moon tonight from the other observers. Thank you. So for the coming month, for May, rising in the east from our latitude is a fairly faint constellation, Serpens Caput. Now, this is actually a very strange constellation because the constellation is Serpens and it's broken up into two pieces. So for this month, we will be seeing the Caput side, and later on in the summer, you'll see the other side of Serpens, which is broken in by the constellation Ophiuchus, the serpent bearer. So this constellation doesn't have a lot of objects in it, but a very bright, prominent one is Messier number 5, or the Rose Cluster. It's a globular cluster, quite bright, will be visible in binoculars. You might just be able to see it as a fuzzy patch with your naked eye if you're in a very dark location. Beautiful, nice globular cluster. It has a lot of, like most globular clusters, very old stars. So if you take a photograph of it, you'll see some of them are quite red. For the next level of challenge, it's going to be quite difficult, but I thought this would be an interesting object, the NGC 5921, which is sort of between the brightest star in Serpens Caput and M5, and a little bit farther up. It's going to be difficult to find visually, but I'm hoping that people will get some nice pictures of it, because this is a real classic barred spiral galaxy. And there's still some debate about whether our own Milky Way is just a regular spiral or a barred spiral. But barred spiral galaxies tend to have a very bright center and a bar, a sort of line of very hot, bright stars down the middle. And then the spiral arms are kind of connected to the ends of the bar. So that's what the shape of this galaxy is, and I'm hoping that we'll see some evidence of that for next month. Even more challenging is this up here. Now I've labeled it as NGC 6027, but there's actually a group of 6 galaxies called Seyfert's Sextet. And 5 of these galaxies are actually interacting with each other, so they're kind of distorting the shapes of them. And then there's one of the galaxies in that same area, still in the same little cluster, but it's actually much, much farther away. So it's not part of the interacting set. But a very interesting little cluster of galaxies, quite faint, quite small. So let's see if you can find that one. And then for the solar system this month, as David pointed out earlier, we have 2 full moons. There's one tonight. If you've got your cameras with you, I've got mine. We can go out after the meeting and see if it's going to show through the clouds. And then right on the 31st of May, there'll be another full moon, and it's sometimes called a blue moon, but no, there will be no color to it from blue. Another interesting interaction with the moon is on May 18th, when the moon is a very thin crescent, and it will be right close to Venus in the western sky just after sunset, or if you're lucky, maybe just before sunset. But the crescent moon will be very, very thin, so you probably have to wait until just, literally minutes after sunset, and you may be able to find it. And Venus will be very, very bright, so it will sort of help you find the crescent moon as well. So those are your challenges for this month. Good luck.
Thank you, Richard. All right. There we go. All right, public star parties coming up. So we've got these scheduled currently, and their rain dates. I guess we'll have these in Astronauts, right, Doug? Yeah, we'll have the dates posted in the Astronauts. So we'll cross our fingers and hope we get some better skies than we had during the winter. It already seems as though things are changing, so we'll cross our fingers on that. And we'll see. So May the 8th, that is next week, in fact. That would be Friday? Friday? Is that right? Have I got that right? Okay, good. And yes, these are the public star parties are at the Diefenbunker in Karp there. It's held in the observing site that's indicated there, which is actually the parking lot for the Diefenbunker site. So we'll cross our fingers and hope that we do get some clear skies on the 8th. You can see the rain dates for that particular party are the 9th, and then 2 weeks hence from that, 22nd and 23rd. All right. There you go. We also have a call for volunteers in terms of bringing. If you're interested in coming to the Star Party, usually draw a pretty good crowd, especially when the weather is nicer and it's not like -20. So for anyone that would like to share time on their telescope and just give people a tour there, certainly looking for volunteers and to help with their telescopes. Or if you just want to give us a hand with traffic control and other support. As I mentioned, these star parties have become fairly popular, and there are times when we get like a few hundred people coming through in the course of just a few hours just to have a gaze and see what we're seeing through our telescopes. Timing is typically 8 p.m. to 10:45. You have to wait a little bit longer now because the days are longer and so the nights are shorter. So if you are interested in helping out, please reach out to Deepinder. He is our Star Parties coordinator, and that is the mailing address that you can reach him at. All right. Fred Lossing. We also have our members-only Star Parties at the Fred Lossing Observatory, where we have our 3 telescopes set up out by Almont. And the next one isn't April 18th, because that just happened a while ago. May the 16th, the night of the new moon, which is, I believe, on a Thursday this coming up in May. We have had one. How did the April 18th one go? I can't recall. Did we have a clear sky that night? I wasn't able to attend that. Was it? Yeah. Okay. We did have some luck back in February, but yeah, the January and March are definitely a write-off. So hopefully we'll make use of the summer months there, and those are the tentative dates of the FLO Star Parties for members only. For those parties as well, we will have access to the 3 main telescopes that we have out there, as well as if you want to set up your own gear there. We have the open areas between the the telescopes that you can use, and we have space on the mounds by those telescopes that are available for setting up your own gear. Pardon me? May the 16th is a Saturday. Yeah. Well, that makes it easier. All right. So just generally club information. Excuse me. Rick Scholes is the man you want to talk to if you have any questions about FLO. Rachel Chen and John Thompson have taken over our library duties. Thank you very much. Peter Shute is the man you want to talk to about any equipment that you might be interested in borrowing from the Ted Bean Loan Library. And Art Fraser is the contact for any RASC membership information that you may have. All right, well, thank you everybody for coming. We have double X. We had quite a few. I think we had, Chris, I think we had 123 in total between what we have here in the auditorium and those that dialed into Zoom. So yeah, it was a good turnout there. Again, probably associated with the half-decent weather that we're getting now. If you have any comments about the meetings, if you have any suggestions, or as I mentioned in my notes out advertising the meetings, if you have ideas for presentations you'd like to give, just drop me a line at meetingchair@ottawa.rasc.ca. And we can discuss that going forward. And again, just to close off, again, sorry for the mix-up in our schedule there. I think Andrea thought that she had the full 2 slots available for her presentation. So we will reschedule her as soon as we can. We'll juggle a few things in the coming months, and we will get her on board. We'll give her the both slots there, because I reviewed her presentation, and there were a lot of stuff there, a lot of good stuff there that she'd like to share with you for getting started in astrophotography. So we look forward to seeing her do that in the very near future. So thank you very much for coming out. We've got our next meeting scheduled for Friday, the June 15th, here at the museum. And yes? Did I say? Oh, well, yeah. Not wearing my glasses. June the 5th. Sorry, got that. Thank you. And again, the rest of the museum is closed as you make your way out. We also have our post-meeting meeting at Liam McGuire's for those that are interested. So thank you everybody for coming out, and wish you clear skies for the month and a safe drive home. And we'll see you next month. Take care.